Why should anyone care about DHCP, DNS, and SNMP in network operations? What significance do these acronyms hold? These are the questions we often hear when we talk about the technical aspects of network operations. Today, let's unravel the importance of these three protocols: DHCP, DNS, and SNMP. Imagine a world where you had to manually assign IP addresses to each device on your network. Remember the IP address of every website you visited and had no efficient way of monitoring network devices. Sounds chaotic, doesn't it? This is where DHCP, DNS, and SNMP come into play. They are the unsung heroes of the internet, working behind the scenes to make our online experiences smooth and hassle-free. Firstly, DHCP, or Dynamic Host Configuration Protocol, is like the postmaster of the internet. It assigns unique IP addresses to each device on a network, ensuring that data packets are delivered to the right destinations. Without DHCP, we'd be stuck manually configuring IP addresses, a task that's not only time-consuming, but also prone to errors. Next, we have DNS, or Domain Name System. It's essentially the internet's phone book. Instead of remembering a string of numbers to access a website, DNS allows us to use easy-to-remember domain names. When you type a website's name into your browser, DNS translates that into the corresponding IP address. It's a crucial link in the chain that connects us to the vast world of the internet. Lastly, SNMP, or Simple Network Management Protocol, is the network's watchdog. It monitors network devices for conditions that require administrative attention. It helps network administrators keep an eye on the health and performance of network devices, making it a vital tool for maintaining network stability and efficiency. So these three protocols, DHCP, DNS, and SNMP, form the backbone of network operations. They ensure that our networks function smoothly, our internet experiences are seamless, and our network devices are well maintained. Let's delve deeper to understand the role of each of these protocols in making our network operations smoother. Think about the last time you connected a new device to your network. Did you ever wonder how it got its unique IP address? This is where DHCP, or Dynamic Host Configuration Protocol, comes into play. DHCP is a network management protocol used on IP networks. Simply put, it's the protocol that allows devices to request and receive an IP address from a server. But how does it work? Well, the magic of DHCP lies in its four-step process: discovery, offer, request, and acknowledgement, often referred to as the DORA process. In the discovery phase, a device, let's say your brand new smart TV, sends a broadcast message into the network seeking a DHCP server. This is like shouting in a room, "Hey, I need an IP address." Next, in the offer phase, the DHCP server receives this broadcast message and responds with an offer. This is the server saying, "Sure, I have an IP address for you." The request phase follows, in which your smart TV sends back a message to the server requesting the offered IP address. This is like saying, "Great, I'll take that IP address, please." Finally, in the acknowledgement phase, the DHCP server assigns the requested IP address to your smart TV and sends an acknowledgement message back. This is the server saying, "Done deal, that IP address is yours now." This dynamic assignment of IP addresses by DHCP not only simplifies network administration, but also reduces the chances of IP address conflict. Without DHCP, network administrators would have to manually assign IP addresses to each device, which could lead to errors and IP address conflicts. And there you have it. The next time you connect a device to your network, you'll know it's DHCP working behind the scenes, assigning that unique IP address to your device. So, DHCP is the unsung hero that ensures every device in your network gets its unique identity. Ever thought about how you end up on your favorite website just by typing its name instead of a complex IP address? It's like magic, isn't it? But as Arthur C. Clarke famously said, any sufficiently advanced technology is indistinguishable from magic. Let's pull back the curtain on this magic, shall we? Enter the domain name system. or DNS as it's more commonly known. Imagine the DNS as the internet's very own version of a telephone directory. But instead of phone numbers, it has IP addresses. You don't need to remember the complex numeric string that forms an IP address. You just need to remember the name of the website, and DNS does the rest. Here's how it works. When you type in a domain name like TechSpectrumPro.com, quote, into your browser, your computer sends a request to a DNS server. This server then translates the domain name into an IP address. This IP address is unique to the website you're trying to reach. It's like the website's home address on the internet. Now, you might be wondering, why do we even need this system? Why can't we just type in the IP address directly? Well, the answer is simple. IP addresses are hard to remember. They are a string of numbers and dots, which can be easily mixed up. On the other hand, domain names are user-friendly, easy to recall, and more intuitive, but there's more to DNS than just convenience. DNS also plays a crucial role in load balancing and redundancy, enhancing the overall efficiency of the internet. It distributes the load of name resolution across multiple servers, ensuring that the system doesn't get overwhelmed. And in case a particular DNS server fails or becomes unresponsive, there's always a backup. This fail-safe mechanism ensures that you can always reach your online destinations without any interruptions. So, the next time you browse the internet, remember the unsung hero working behind the scenes. The DNS, translating complex IP addresses into simple domain names, making your internet experience seamless and enjoyable. DNS is essentially the internet's phone book, ensuring you reach your online destinations with ease. How do network administrators manage and monitor thousands of devices in a network efficiently? The answer lies in the magic of SNMP, or Simple Network Management Protocol. SNMP is a protocol designed for network management. It's a set of standards for communication with devices in a TCP/IP network. Simply put, SNMP is the handyman of network management. It's used to manage and monitor network devices like routers, switches, servers, printers, and more. Let's break it down a bit further. SNMP operates on the basis of agents and managers. An agent is a software module that resides in a network device. It collects and stores information about its host device's performance. On the other side, there's the manager. The manager is a separate device or software that communicates with the agents to collect and process their data. Now, you might be wondering, why is SNMP so crucial? Well, SNMP provides network administrators with a bird's-eye view of the network's health. It allows them to monitor network performance, find and solve issues, and plan for network growth. Imagine a scenario where a router in your network is experiencing issues. Without SNMP, diagnosing the problem could be like finding a needle in a haystack. But with SNMP, the manager receives a notification about the issue. It can then query the problematic router's agent for more information, allowing for targeted troubleshooting. Moreover, SNMP isn't just reactive, it's also proactive. It helps administrators anticipate issues before they occur. For instance, SNMP can alert administrators if a device is nearing its capacity, giving them the chance to upgrade or replace the device before it becomes a problem. In essence, SNMP is like the central nervous system of a network. It gathers information, processes it, and initiates necessary actions to maintain the network's health. It's a vital tool for network administrators, ensuring efficient and effective network management. With SNMP, network administrators can keep a tab on network performance and troubleshoot issues in real time. It's not just about solving problems. It's about foreseeing them and ensuring the network's smooth operation. That's the power of SNMP. Let's recap what we've learned about DHCP, DNS, and SNMP in network operations. In the realm of network operations, DHCP, DNS, and SNMP are the unsung heroes, the silent workers that ensure a smooth and efficient communication and management. Each of them plays a unique and vital role. contributing to the overall functionality of the network. The Dynamic Host Configuration Protocol, or DHCP as we commonly know it, is the network management protocol used on IP networks. Its primary role is to dynamically distribute network configuration parameters, such as IP addresses for interfaces and services. It's like the concierge of a hotel, assigning rooms to guests, ensuring no two guests have the same room. Next, we have the Domain Name System, or DNS. Think of DNS as the phone book of the internet. It translates human-friendly domain names into IP addresses that computers use to identify each other on the network. Without DNS, we'd have to memorize a series of numbers for every website we want to visit, which is, as you can imagine, not very practical. Finally, we have the Simple Network Management Protocol, or SNMP. SNMP is the glue that holds everything together. It's a protocol used for managing devices on IP networks. It collects and organizes information about managed devices on IP networks and modifies that information to change device behavior. It's like the control center, keeping an eye on everything, ensuring that all parts are working correctly. Each of these protocols, DHCP, DNS, and SNMP, have a unique function, but they all work together. DHCP assigns IP addresses, DNS translates these addresses into human-friendly domain names, and SNMP manages and monitors the network's performance. In the vast world of network operations, DHCP, DNS, and SNMP are the silent workers, ensuring smooth and efficient communication and management. These protocols are the backbone of the internet as we know it, silently working in the background, making our online experience seamless and effortless.